Hello and welcome back. We're working through some of the sample problems on your section 1.4 homework. I'm on number 11 now. Number 11 asks you to solve by completing the square. Now, actually, I won't know which method you use. You can just type in the answer and use the method you want. But for a demonstration of how this would work by completing the square, I'll go through it that method. So to complete the square, you have to have a 1 coefficient. And we do here on this example. If not, you have to divide through by whatever the coefficient of the squared term is. So we're ready to go there. Step 2, we take the constant across the line. And the reason for that is we're basically making a new number that completes the square on the left side. So the 36 is not the right number to complete the square. So we always take the constant over and start fresh. Then to what's called complete the square, you half this middle term and square it. And that will always make a perfect square trinomial on the left side that completes the square. So again, the magic is half squared. So half of 5 is a fraction actually. So it doesn't half very well, but we can still do that. Leave it as a fraction, 5 over 2, and then square it. That squares the top and bottom, making a 25/4. So the number that completes this square is 25/4. So we'll be adding 25/4 to the left, and we'll have to compensate by adding 25/4 to the right. Now, what we've got is x squared minus 5x plus 25/4 equals 36 plus 25/4. This side is now guaranteed to factor. It always factors into x and x to be the x squared. And then in this case, it'll be minus times minus to get a positive on the end and a negative in the middle. And what you need is 5 over 2, back to that square root that we had earlier, the 5 over 2 from above, or the 5 over 2 because that's the square root of 25/4. If you FOILed this, the first is x squared, the last times last would be 25/4, and the inner and outer would combine to be the right middle term. So without doing that every time and overthinking that, we just know it always factors into the square roots of these ends. If we've completed the square correctly, we just bring down these two square roots and this middle sign, and it will be that squared because it's times itself. Then we have to do a little math on this side to work this out. And you can use your calculator if you want. I'm going to have to do a little math here quickly myself to see what I've got. So I'm punching this in my calculator, and I've got 144 fourths plus 25 fourths, or just completely do that on your calculator and get 169 over 4. Okay, so we combine those two on the right. Then we can use the square root property and square root each side. The square root and the squaring cancel each other out and brings down what was under the radical. It releases that part. Now, luckily on this side, when you square root, you will get perfect squares of 13 and 2. And we do need to say plus minus. When you use the square root property, it's always plus and minus to get our two answers. So x equals, throwing this across the line, 5 over 2 plus and minus 13 over 2, which can be further worked out to 5 over 2 plus 13 over 2 and 5 over 2 minus 13 over 2, which will be 18 over 2, or 9, and 5 minus 13 would be negative 8 over 2, or negative 4. So two answers, 9 and negative 4, are the final two answers there. So actually, if thinking about it and kind of wondering what other methods I could have used here, this was very much factorable from the beginning. It factors into x minus 9 and x plus 4. And we could have quickly factored that and then set each factor equal to 0. When it comes out to be these nice rational answers, that means it was factorable from the beginning. And this method also confirms we get our two solutions of 9 and negative 4. But this completing the square method, it is a never fail method. You can always go through this with any quadratic equation. Sometimes it's not the easiest method, so not necessarily your first choice for how to solve all the quadratics, but it has its place. there are times when we need to use this method. An example will be in the next chapter when we'll find the center of a circle. All right, but I hope that helps on number 11. All right, let's look at the next one, number 12. So on number 12, my example I have here, it's completing the square again. And like I said before, you can do it with other methods and answer it. But this is just for our practice to make sure we know how to do this method when needed. So we can only complete the square when there's a 1 coefficient. So since there's a 2 here, we'll have to divide everything by 2. And as long as we divide both sides by that 2, we're allowed to do this. That reduces this 2 over 2 to 1x squared. It makes that a 9 over 2x and a 1 over 2. And then 0 over 2 is just 0. Then to complete the square, after the coefficient is 1, we take the constant across the line. And we try to figure out the right number that completes the square. So this 1/2 is not it, but throw it across the line to start fresh. So the number that always completes the square is half the middle term squared. So we have to figure out what is 9/2 divided by 2, or that would be times a half. So 9/2 times a half, we can multiply that on our calculator or here by hand, is 9/4. Then you square that. So remember, the completing the square is half the middle square. So half of 9/2, that means 9/2 times a half is 9/4. And then squared will be 81/16. So 81/16 is the special number that completes the square on this example. So that's what I add to the left and I add to the right. All right, so this is just my work to figure out what to complete the square, since I couldn't just do it in my head. Not easy numbers to half and square. But now back to my problem. Now that I've added in the right number to complete the square, I'm guaranteed this side factors. And so I told you on the last example, don't worry about trying to factor it. Just trust if you've got the right number, it's just the square root of these n numbers. So x and back to the 9/4, the square root of that. And then the middle term here is positive, so it'll be positive as well. Then I need to combine my fractions. Again, you use your calculator to do these. And that is going to give me what? 8. That's going to give me 89/16. And again, you can do that on your calculator. Now, sometimes when this program regenerates values, some problems are harder than others. And I'm thinking this looks like one of those, harder than others, because when I square root both sides to solve this, that is not going to divide out or square root out evenly. I'm going to still have an irrational number. But that's okay. Just know that it's not going to be as neat and tidy as the last one. When I do plus and minus of this side, the square root of 89 will not reduce, but the square root of the 16 on the bottom comes out as a 4. So it reduces a little bit. And we do need the denominator to reduce out or to not have a radical left in it. So that's good that that happened. Then I throw the 9/4 across the line, and I have negative 9/4 plus and minus the square root of 89 over 4. And actually, it's kind of good in some ways because there's nothing else we can do to that. We cannot reduce that any further because the square root of 89 is not a perfect square, nor does it contain one. So that is how I leave that answer. Okay, and then moving on down to number 13. Number 13, we shift gears to the quadratic formula. We're going to do number 13 with the quadratic formula. So before you use the quadratic formula, which is negative b plus and minus the square root of b squared minus 4ac all over 2a, we have to determine our a, b, and c of our quadratic. Now, it's not in standard form, so I will need to move the 20 across the line, making that y squared minus 10y plus 20 equals 0. Again, it must be in standard form before you proceed. So a is the coefficient of the squared term, which is 1 here. B is the middle coefficient, negative 10, and c is the constant, 20. And then I throw these numbers into the formula and work through the process. So the negative of b makes that positive 10 plus and minus b squared. Now you're going to square the negative sign as well. So don't forget the negative is squared when we plug a value in for a variable. It's as if there's a parenthesis around it. So the negative will be squared, also making it positive 100. Minus 4 times a times c, all over 2 times the a value. Then next I would reduce what's under the radical. Don't worry about the 10 and the 2 until the last thing. Get the radical reduced. And you can use your calculator. Plug this in. Negative 10 squared is 100. Then minus 4 times 1 times 20 will be minus 80 all over 2. So 100 minus 80 is 20. And then square root of 20, again, not a perfect square, but this one is reducible. We can reduce the square root of 20 a little bit. Square root of 20 can be broken apart into a square root of 4 times the square root of 5. The square root of 4, because it's a perfect square, reduces out to a 2. So we're able to reduce this down to 10 plus and minus 2 radical 5 over 2. So you should always reduce your radicals if they're reducible. It's not acceptable to leave them with a decimal in the decimal approximation on your calculator, unless the directions specifically say it's okay. Usually it says type an exact answer, so it wants them more exact. Using radicals is needed. So this is it. Then the last step, if you can reduce, if there's something common for all three parts, like this 10 divides by 2 and reduces to a 5, as well as these two terms reduce. So both of these, there's two terms there, divide by the 2. So 10 divides by 2, as well as this divides by 2. And in this case, the 2's cancel, and then that would be your final answer. Now, if there's not a plus minus button on your tool there to use, you can always type it in as two separate answers, because that's what this is, two answers, the two answers to our quadratic equation. All right, I hope that helps.